Hello everyone. I'm going to go over our week 2 labs. I'm going to do this in 2 separate videos so that the video recordings aren't too long. It'll be a little bit too cumbersome. The first one I'm going to do is the graphing part of the lab. So let me share that with you and then we will go over that. Okay. So the objective of this lab is to make sure that you know how to construct and interpret graphs. One thing that you really need to understand is the difference between an independent and a dependent variable. The independent variable, first of all, is always on the x-axis. It's always the horizontal axis. And the dependent variable is always the y-axis or the vertical axis. So the independent variable is the one that the experimenter controls or changes, whereas the dependent variable, its value depends on the other variable. So if we look at this example right here, for Rhode Islanders who admit to texting while driving, if you have a variable that's called time, time is always the independent variable because that is what the experimenter is manipulating, like how often he takes measurements, for example. In this particular example, it's over a number of years. So time would be our independent variable that would go on the x-axis. The number of people at each time point would then go on the y-axis. Okay? So you need to make sure that you understand the difference between those two. And then when you're constructing a graph, a couple of things you always have to have on a graph. You have to have a title that's appropriate to the data you're graphing. You have to have labels on each axis. So for example, with our data up here, my x-axis would be time, and then you have to include units. So you'd put in parentheses years. My y-axis would be number of people, in parentheses, in thousands. Okay? So you have to label the axis, you have to give it a graph. And when you are constructing your graph on your graph paper, I mean, you either use graph paper, or a lot of people use computer now, but you want to make the graph large enough so that everyone can see it. So if you're using graph paper, you want to use as much of the graph paper as you can, as is practical. You don't want your graph to be all scrunched up in a corner so no one can read it. Okay? So make sure you use enough of your graph paper. The other thing is, you're not going to do a dot to dot. You're not going to connect the dots on your graph. What you're going to do is you're going to make what's called a line of best fit, where you would lay your straight edge or your ruler, you try to touch as many points as you can, and you would draw a straight line through your data set. If it's a curve, you try and draw the smoothest curve possible through your data set. You don't go point to point to point. Another thing that's handy that I do all the time is I use different colors. If I want to use the same set of axes, I could simply use a different color for my line, or I could use a different symbol for my data points. Okay? So that's important. Now, if we look at the graph of Rhode Islanders who admit to texting while driving, we plot that data, it looks like this. So over the years, the number of people who admit to texting while driving has dropped significantly. This is called an inverse relationship. This is where one value is going up, the other is going down. So as time is increasing, number of people is decreasing. That's an inverse relationship. As opposed to this particular graph here, where you see the line going up, that's called a direct or a linear relationship, because as one variable increases, so does the other. Okay? So now here is some sample data that you will be responsible for graphing. So again, we have a time variable, which means that time would be your independent. And now you have two different trees. So you're either going to need to use two different symbols or two different colors. And you can graph all that data on one set of axes. So your graph is going to have two lines on it. And then you are going to come down here and you are going to answer the questions. And then it asks you at the bottom to use your graph to estimate the height of the maple tree at 3.5 years. So you look on your x-axis to approximately 3.5, and you look up to where your line is, and then you can read over and figure out what the height would be at that particular point in time. Okay? And I don't think this is particularly difficult, this part of the lab. But again, just make sure you do your graph. If you don't have graph paper, or if you don't have that program on your computer, Professor Johnson has included a PDF and a doc file that has a piece of graph paper. Okay, again, do your graph, either upload it to me, take a picture of it, and send it to me. Okay, so that's part 1 of Lab 2, graphing. I'm going to record a separate video for the second part of the lab, which is making measurements using the metric system. Okay, good luck. Thank you.